In this video, I will show how to use the properties of quadratic functions to solve an applied math problem. So let's read the question. A landscape engineer has 200 feet of border to enclose a rectangular pond. So as we're reading the question, let's draw a picture. So we have a rectangular pond, which we're trying to enclose. So we're trying to construct a perimeter here. And what dimensions will result in the largest pond? So let's introduce some variables. So if I let x be the width of this rectangle, then let's also introduce y to be the length of the rectangle. So the first relation that we can write is the sum of all the lengths must be equal to 200. Therefore, x plus y must be equal to 100. Therefore, y, the length, depends on the width in the following way. So if the width is x, the length has to be 100 minus x. Now, if we're trying to create the largest pond, that means we're trying to create the pond with the largest area. So the area for such pond will be written as, or can be written as a function of x, which is basically take the width and multiply by the length, which is written as a function of the width. So basically, once we choose the width under this constraint that we have only 200 feet of border to enclose, the area function is this. Now we're trying to find the largest value of this function, but first let's take a look at what type of function this is. If I distribute everything and rewrite this function, it is easy to see that this function is quadratic, and as every other quadratic function, it has the graph, which is a parabola, and in this case, since the leading coefficient is negative, it is a parabola that opens down. And as every parabola that opens down, this parabola has a maximum value, which is always at the vertex. So to answer this question, what dimensions will result in the largest pond, we interpret as the question about finding the vertex of the parabola, which is the graph of this equation. Now to find the vertex, I'm just going to use the following relations. That is, the x-coordinate of the vertex is negative b over 2a, and the y-coordinate of the vertex is the value of the function at negative b over 2a. In this case, a is negative 1 and b is 100. So to find x, we simply plug it in and we get 50. So the largest dimensions, the dimensions that result in the largest pond are x equals 50 and y equals 100 minus 50, which is also 50. So the pond must be 50 by 50 feet. Now, even though this question doesn't ask for the largest area, we can easily find it by evaluating the area function at 50. So 50 times 100 minus 50 is 2500. So the largest area is 2500 feet squared. So this is how we use the properties of quadratic functions to solve an applied math problem.